So, dear students, welcome to our class on JRF SRF Net 2022 Agriculture Meteorology Advances 8. In this class, we try to continue what we studied in the class Advances class number 7, that is the atmospheric boundary layer. As I said, the atmospheric boundary layer, depending upon the region, whether it is a torrid zone or you can say arid zone to temperate zone, like that, 1 to 2 kilometers into the troposphere, we call it as the atmospheric boundary layer, ABL. So the basic characteristics, there are three layers or three regions of the atmospheric boundary layer during a course of 24 hours. A surface layer or constant flux layer is there, a mixing layer is there, and then potentially there is a stable layer. Both those characteristics we discussed in the class number 7, how they come in the form of bits. In this class, we try to understand what is stable, what is unstable, what is neutral atmosphere, and in that the most basic bits we try to understand. See, basically in the fundamental course, we try to understand gases, free path, when there is a exchange of flow, exchange of flux, exchange of flux, whether it is momentum, mass, or heat flux, when it is taking place in the form of small molecules, we call it as air molecules. So there we consider free path, FRAE, free, PATH, free path, that is the distance between two collisions in exchanging of the flux, or properties. So what is the mixing length, we try to understand. So if eddies are there, they mix it. Unlike molecules, eddies are pockets of air, Eddies, as the energy is there during the daytime, they become very, very big, and then by evening, in the absence of the energy or after sunset, eddies collapse. So that's what. So basically, the size of gas molecules are mostly uniform, that's it. And the eddies are not in the uniform size. Similarly, there are the molecules exchange the direction and exchange momentum in discrete instances, called collisions, whereas gas molecules, through collisions, they exchange the momentum, whereas eddies exchange the properties by mixing. That is why we defined mixing length in class number 6. I defined. So just for your academic interest, which may come, that's why I am worried. I would like to share with you what is the mixing length. See, if a eddy is there, a parcel is there, when a parcel is retaining its own characteristics, and then while it is moving, it mixes with what is mixing length? It mixes with the property by losing its own properties and gaining the properties of the other layer in general. From this layer to another layer, a parcel of eddies travel. They have their own characteristics, but they lose their characteristics by entering into another layer. So the length we call it as the mixing length. This is very much useful in several applications. That's what we discussed in class number 6. That's why I am interested to inform you once again that if you assume that it is as discrete patches of air, then in turbulent atmosphere there are packets of air known as eddies. In the turbulent atmosphere there are packets of air. What is turbulent? That we have discussed already. No need to explain. Several times, even in the theory. That's why I request you, please subscribe to our channel, Agrometeorology Farmers in Rural Development. Theory of micrometeorology I have covered extensively. Now here only from the bits point of view, important points which they come in the form of multiple choices only, but in the net you may be asked to write and then in ARS exam, so that's why. Now see, nearly all the natural motions of the air are turbulent in general. All the movements that are taking place, particularly in the atmospheric boundary layer, they are turbulent. Now air moving over the ground experiences friction naturally. Air moving over the ground, it experiences friction. Friction means there is some sort of drag. Which is a drag? Resistance. Dr is a drag is resistance. Now, so the forces moving the air and the retarding frictional forces can cause the air to rotate and break up into eddies. So these are the basic properties of molecules and eddies. Molecules are constant in size, eddies are not. They move in pockets, Eddies you find only during the daytime when energy is available. Now, see, if you take the temperature profile, in the atmospheric boundary line, usually what happens is you find three situations. Number one, neutral situation. Number two, unstable. Number three, stable situation. What are these? Bits may come in any form. That's why. Now, we try to understand neutral temperature profile. Okay, temperature profile. Let us take only one temperature. Neutral temperature profile. Okay, what is neutral temperature profile? Now, here there are 2 to 3 bits that are possible. The neutral temperature profile is one in which a potential temperature remains constant with height. What is potential temperature? If you assuming that you are adiabatically you are trying dry adiabatically you are trying to take a parcel at 273.15 degrees Kelvin and 1000 HPA. Okay, so that's what is potential temperature. Now here with reference to neutral temperature profile is the one in which the potential temperature remains constant with height. This is one bit. Potential temperature remains with height. Potential temperature remains constant with height is known as, that's what I am telling you, neutral temperature profile. This is number one. Second characteristic is this occurs on three conditions. Overcast, that means cloudy day, both during the sunrise and sunset. During these times, what happens? The potential temperature remains constant with the height. Now, so in the neutral conditions, temperature has no influence on the friction-driven vertical transport of matter and energy. The eddies are symmetrical in neutral conditions. Eddies, as I said, eddies and molecules, difference I told So eddies are symmetrical in shape in the neutral conditions. Now, what are the unstable conditions? Let us see what is unstable condition. So during these are possible bits. During clear summer days or very hot sunny day, the ground absorbs radiant energy and its temperature increases more rapidly than that of the air above it. So sun's rays are falling on the surface. So sun's energy is absorbed by the surface and it radiates. So here there is more heat near the surface of the earth as compared to air above it. That is number one. Consequently, the temperature decreases with height. In the troposphere, the basic characteristic feature of troposphere is the temperature goes on decreasing as the height increases. Now, as the temperature decreases with height above the surface, it is known as what we call it as usually lapse rate. That's what the rate of change of temperature due to rate of change of pressure, we call it as lapse rate. Dry adiabatic lapse rate is 10 degrees centigrade per kilometer. Wet adiabatic lapse rate is 5 degrees centigrade per kilometer. Average adiabatic lapse rate is not 10 plus 5 by 2 is equal to 7.5. It is 6.5. Average adiabatic lapse rate 6.5 degrees centigrade per every kilometer. Here, in the unstable conditions, what happens is the air near the surface will be less dense. The air near the surface of the earth will be less dense because more energy is there. It had expanded. See, the density of air, decreases as the temperature or heat energy is entering into that gas. Universal gas, universal constant, that I have covered in the basic course. Agrometeorology, climate change. That's why I request you please subscribe to our channel. Fundamentals are there in the advanced classes applications. So if I go on talking fundamentals, it may not be very interesting to beloved students. That's why I would like to request you please subscribe to our channel. Learn the things that I have covered in the basic courses. Here the unstable layer, okay, unstable condition, the air near the surface will be less dense and more buoyant than the air above it. Near the surface of the earth, it is less dense and more buoyant. Buoyant forces are there. So the atmosphere is unstable and vertical transport will be enhanced. Why vertical transport is enhanced? It is because the atmosphere is unstable. Why atmosphere is unstable? Because the basic conditions, scientific reason for unstable atmosphere is as the height increases in the troposphere, particularly 1 kilometer, where we talk of atmospheric boundary with reference to our agricultural meteorology, we are confined with only little part of the atmosphere, troposphere, maximum stratosphere, that much. So here the basic characteristic feature of the unstable atmosphere is as the height increases, the temperature goes on decreasing, only that much. That's why. So there is a very hot and less dense air near the ground, and as compared to above it, and the temperature goes on decreasing. That causes an excellent phenomena called as vertical movement of the eddies. Eddies goes on developing a convection. Okay, good. Through convection process, cumulonimbus clouds may form on a very hot sunny day if enough moisture is there. So a lot of weather phenomena occurs. That's why troposphere is known as seat of weather phenomena. So atmospheric boundary layer, when it is unstable, there is a possibility for storms. When dust is added, dust storm, you get it. These questions may come in any form, bits may come in any form. So this is with reference to unstable atmosphere. What is a neutral atmosphere? Potential temperature is remains constant as the height increases. That is the basis. What is potential temperature? So 1000 PHA, okay, and 273.15 degrees centigrade, presuming that the dry adiabatically air parcel is taken. So that particular potential temperature remains constant under three conditions: under the cloudy condition, both in the morning as well as in the evening. Now here, what is stable? Let us try to understand. The stable layer is during the clear nights, during the night time, for morning 6 o'clock, okay, evening 6 o'clock, okay, in the tropical regions, for example, morning 6, sunrise at 6, sunset, good. Then what happens after the 6 p.m.? After 6 p.m. what happens is stable. The atmosphere becomes stable. How and why? Because during the clear nights, the ground loses the heat. There is no source of energy like during the daytime. So what happens? The heat source itself is, the earth itself is the heat source. So it loses. Once it loses the heat in the form of log wave radiation, and surface cools below that of the air. Below that of the air, surface cools. Surface, when you are walking, you feel cool. You feel cool in your bare feet as compared to the air. Very comfortably you can breathe. So like that. The air adjacent to the surface is moisture, dense, and the atmosphere is stable. So here it is known as the inversion, and the friction driven vertical transport is damped down. Damped down. So what exactly does it mean? In the stable atmosphere, two basic characteristics are there. It happens after the energy received is no more. That means after the sunset. Why? The ground loses all the radiant energy, because the ground itself or surface itself is the source of energy. It loses the energy, so that it becomes cool, and dense air is there near the surface of the earth. Okay, from the surface layer. Surface layer is the constant first layer. Now, so above that surface layer, you find inversion. So that means as the height increases, the temperature goes on increasing. Why? Because in the absence of heat and loss of heat by earth, dense air is there, which is very, very cool, and then inversion takes place. Under the inversion conditions, the atmosphere is stable. So if you wanted to know more differences between the stable and unstable, okay, it will be I have summarized them with in a very simple way for your academic interest. Stable air Stratiform clouds and fog you will find. Stratiform clouds and fog you will find in the stable air. In the unstable air, cumuliform clouds you will find. Continuous precipitation you find in stable air. Under unstable air, showery type of precipitation. It's not rain, it's a shower. Sometimes drizzle type of precipitation you find. Third one, smooth air you will find in the stable air. Rough air you find in the unstable air. Okay, now fair to poor visibility you find in the stable air. Good visibility except in blowing conditions you will find in the other situation. Now, it may rain or snow slowly but steadily under the stable condition. Atmosphere is under the stable condition. It may rain or it may snow. Okay, snow you get it, but steady you get it. So weather is subjected to high degree of variability in the unstable air. Next, under the stable air, it may be sunny, but the weather will not change quickly. Stable conditions, stable atmospheric stability, stable air. The weather won't change all of a sudden, but under the unstable conditions, the weather may change with little warming. Even half an hour increase in temperature changes the atmosphere stability, and a stable atmosphere will tend to resist vertical motion. A stable atmosphere resists vertical motion of eddies, okay, from one layer to other layer to other layer. A unstable layer assists vertical motion. So these are the basic differences. Finally, the last bit, these differences may come in any form, in the form of bits. Just to sum up like this, stable air basic characteristics are, stable air first I read. Stratiform clouds, continuous precipitation, smooth air, okay. Either rain or snow, they occur continuously. Even under high warming conditions for few hours, there is no question of change in the atmosphere quickly, and the stable atmosphere will tend to resist the vertical motion. So under the stable air, these are the things. Unstable air, cumuliform clouds, showery precipitation, rough air, weather is subjected to high degree of variability. Even with 1 or half an hour or 15 minutes of high temperature, the weather may change with little warming. In other words, weather is subjected to high degree of variability, and the unstable air assists in vertical motion of the eddies. Now, last bit for today's class is conditional stability. Usually, this bit will come, the atmosphere is normally conditionally unstable. This bit will come. Atmosphere naturally is conditionally unstable. Now, let us say what is conditional stability, then you will understand what is conditionally unstable. First, let us define conditional stability. Now, it is defined as the environmental lapse rate is between wet and dry adiabatic lapse rates. The environmental lapse rate is anywhere between dry and wet adiabatic lapse rate. As I said, dry adiabatic lapse rate 10 degrees centigrade per kilometer, wet adiabatic lapse rate 5 degrees centigrade per every kilometer. Now, anywhere between these two, we call it as the conditional atmosphere is in the conditional stability. However, always the atmosphere is conditionally unstable. Exactly, you will find what is unstable from the discussion and from the differences we have discussed. Thanking you very much for your very patient hearing.